Our next topic in network laws and theorem is the superposition theorem. So as applicable to AC networks, the principle here is the same as in DC network. So it states as follows: in any network made up of linear impedances and containing more than one source of EMF, the current flowing in any branch is the phasor sum of the currents that would flow in the branch if each source were considered separately, all other EMF sources being replaced for the time being by their respective internal impedances. So if any. So if there is no internal impedances, just short the other sources. So this is our original circuit. We have two sources, the 120 angle 30 and the 120 angle negative 30. And we have impedance 1 to be negative J2 ohms. Impedance 2, 2 ohms. Impedance L is 6 plus J8 ohms. So we are required to solve for the branch currents I1, IL, and I2. For superposition theorem, we will consider first our one source and other sources will be shorted. We will consider 120 angle 30 and 120 angle negative 30 will be shorted. We will name branch currents to be I1 prime, IL prime, and I2 prime. Now we will solve all of these branch currents using applicable theorems or simply series parallel circuits. For this one, we can solve this with Ohm's law or series parallel circuit. First, for us to solve I1 prime, we must solve first the total impedance and then the total voltage source divided by the total impedance will be our I1 prime. So for this one, as we can see, impedance L and impedance 2 are in parallel. Okay, so Z2L is equal to Z2 in parallel with ZL. That is equal now to 1.75 plus J 0.25. After we parallel this circuit or this impedance, we will now take the total impedance. Taking the total impedance is equal to Z1 plus Z2L. So that is equal now to 1.75 minus J 1.75 ohms. Now we are ready to solve I1 prime. So E divided by ZT is equal to 120 angle 30 divided by 1.75 minus J 1.75. That is equal to 48.487 angle 75 degrees amperes. Using current divider theorem, we can solve your IL prime and I2 prime. For IL prime, this one, taking the total current supplying this branch multiplied by the parallel combination of Z2L divided by the impedance L. That is 48.487 angle 75 times 1.75 plus J 0.25 divided by 6 plus J8 equal to 8.571 angle 30 degrees ampere. For I2 prime, you can solve this one using CDT or KCL. So for KCL, you will have your KCL at this node. So I2 prime is equal to I1 prime minus IL prime. Or for CDT, I2 prime is equal to I1 prime, this is prime, times Z2L divided by Z2. That is equal to 42.857 angle 83.13. So after solving the branch currents using this source, we now go to the other source. Short-circuiting the first source. So using 120 angle negative 30 volts, we will now solve I1 double prime, IL double prime, and I2 double prime. For us to solve the I2 double prime for this circuit, because it is your source current, I mean total current. So solving the total current, we will first solve the total impedance. So here, this is our impedance 1, impedance L, and impedance 2. Z1L is equal to Z1 in parallel with ZL. That is equal to 0.333 minus J2.333 ohms. Getting the total impedance, Z2 plus Z1L is equal to 3.3 angle negative 45 ohms. Solving now, your I2 double prime is equal to E divided by ZT. Our E will be 120 angle negative 30 divided by 3.3 angle negative 45 equal to 36.365 angle 15 degrees ampere. So solving for IL double prime using CDT again. You discussed this one in your circuits 1 already, the CDT. So I2 double prime multiplied by Z1L divided by ZL. That is 8.57 angle negative 120 degrees amperes. You can solve I1 double prime by KCL or CDT. So in this case, I used CDT. So I2 double prime times Z1L divided by Z1, that is 42.85 angle 23.123 degrees amperes. So after getting all the branch currents for these two sources, we will now superimpose the currents versus our original circuits. So this one, our basis will be the direction of currents. So as we can see here, I1 is going to the right and I1 prime is going to the right, so that is positive. I1 going to the left is opposite direction, so it will be negative I1 double prime. For I2 is in to the left direction. I2 double prime is also the same direction with I2. So I2 double prime is positive and I2 prime is in opposite direction. So it will be negative I2 prime. For IL downward and IL prime downward, IL double prime downward, so they are in the same direction, so it is the sum of IL prime plus IL double prime. So this is now your final currents. I1 is equal to 40.272 angle 131.83 degrees amperes. I2 is 44.7 angle negative 47.845 degrees ampere. And IL is 4.436 angle negative 44.988 degrees ampere. So you can recheck this one using Kirchhoff's and Maxwell's theorem.